All right, so section 10-2 or 10.2 is finding ratio values of a triangle. So you're basically just going to use the triangle that you're given and a specific definition of the sine, cosine, or tangent function to tell me the answer that they want us to write out. Okay, now they're going to be exact values, so you'll notice the answers tend to be in terms of like radicals, like no decimals. Okay, it's going to have like radicals or fractions, stuff like that, but no decimals involved. Okay, so before we go into this though, we have to introduce the main definition. So what we're going to do is come over here and write those out. All right, now there are 3 trig functions that you have to know. I mean, there's actually 6, but we're just going to worry about 3 of them. So first off, we're going to learn about the sine function. So sine of theta, okay, that symbol right there that looks like a 0 with the line straight across, that's called theta. It's a Greek alphabet letter, okay. A lot of times for angles, we tend to use alpha, beta, gamma, delta, epsilon. We'll use phi, and most of the time for angles, we use theta. Okay, so that's all Greek, okay. And we tend to use a lot of Greek in trigonometry. So the most common one, though, is theta. So don't worry about writing those down. You don't need to. But the most common one for an angle is theta. Okay? So sine of theta, theta, okay, theta. Sine of theta is equal to opposite divided by hypotenuse. Now, they're assuming that you guys know that the hypotenuse is the side that is opposite the 90-degree angle. Okay? So they're assuming that you know what the hypotenuse is in a right triangle. All right? So I'm going to assume the same thing. Okay? So there's the definition of one trig function. Sine of theta is equal to opposite over hypotenuse. Some people abbreviate this by saying SOH. So. Okay, they say so. SOH. Sine is opposite over hypotenuse. So those 3 letters kind of help you remember what pieces go where. Yeah. Now, cosine. Cosine of theta is adjacent over hypotenuse. Whoops. Okay, so people will abbreviate this as CA. All right, CAH. So cosine of theta is equal to adjacent over hypotenuse. Now the word adjacent means next to, the side next to. So we'll remember that right there. Opposite means the side opposite of. So for sine, we're looking at the opposite side and the hypotenuse. For cosine, we're looking for the adjacent side, so the side next to the angle, and the hypotenuse. All right? And then there's one more. Tangent. Tangent of theta is opposite over adjacent. And people will abbreviate that as TOA. So a lot of people, to try to remember these definitions, they say SOHCAHTOA. Okay, SOHCAHTOA. That's the way they remember it. All right, now just to draw you a really quick picture of what adjacent and opposite and hypotenuse look like, let me just do that right here really quick. So I think I can do, no, I can't do one of those. If I do this, now remember, we're going to be dealing with right triangles. Right triangles means that there's a 90-degree angle somewhere. The reason why I know there has to be a 90-degree angle is because they mention hypotenuse. And the hypotenuse requires a 90-degree angle. Okay? This is the hypotenuse. Notice how it's opposite the 90-degree angle. Okay? So it's on the other side of it. All right? So the hypotenuse is opposite the 90-degree angle. It's also the longest side. If you look at a picture, it'll be the longest side. Okay? But sometimes it's a little tough to tell. So just remember, it's the opposite side of a 90-degree angle. Now, let's pretend that this is the angle in question. This is my theta. The opposite side of that is over here. Opposite. I always tell people, think of that angle like an eyeball, right? Think of it like an eyeball, and here are the eyelashes, right? Where is it looking at? It's looking straight across. So that's your opposite side. Okay? So think of it kind of like an eyeball that's looking across from it. Okay? So that's how you can tell your opposite side. And notice your adjacent side. You see how it touches that angle? This side is actually touching the angle. You'll notice whenever you do a triangle, there will always be two sides touching the angle. One is the adjacent, the other one is the hypotenuse. The only side that does not touch the angle is the opposite side. Okay? So there's a couple ways for you to kind of figure stuff out. Like if they ever tell you what's the opposite side of this angle, well, ask yourself, which side isn't touching the angle, right? I can see this side right here does not touch the angle. That must mean that's the opposite side, right? If they ask you for the adjacent side, then it's either here or here. Those are both adjacent to the angle. They're both touching the angle. But the way you can decipher between which one's adjacent and which one's hypotenuse is to actually figure out the hypotenuse first, right? And the hypotenuse would be the longest side, or the side that is opposite the 90-degree angle. Once you label your hypotenuse and your opposite sides, the adjacent one is the leftover. Okay? I would recommend when we do these problems, label your sides. Literally write OPP for opposite, ADJ for adjacent, HYP for hypotenuse. All right? So here we go. Let's look at these problems here. So, sine of theta. Now just to write down our formula here, sine of theta is opposite over hypotenuse. Now look at this picture. Okay, let me label, and I kind of hate the fact that this thing is so crowded. Let me redraw it. Here's 90. All right. My hypotenuse is going to be this side right here. So I'm going to label it right there just because it's a little hard to see because everything's so crowded. Okay. Notice my angle is right there on the bottom left. So if the bottom is the hypotenuse, where is the opposite? Is it going to be A or B? Which one is the opposite side? B, right? So I'm going to write opposite. So this is my opposite. Okay? That means that I only have one option for the last side, which would be my adjacent. Okay? It's going to be my adjacent side. So here it is, ADJ. So all I'm going to do is get my formula, sine of theta. What is my opposite side? What is the value of it? 12 square root of 2. Thank you. What's my hypotenuse? Well, I don't have anything, right? I don't have anything for my hypotenuse. How do I figure out the third side of a triangle that's a right triangle? Do you guys remember? Anybody remember how you find pieces of a triangle? So again, they're assuming that you guys remember everything you've learned before. Do you guys remember this? Anybody remember that term? The Pythagorean. Anybody remember what it was? I'll give you a hint. A squared plus b squared equals c squared. Okay? So a squared plus b squared equals c squared. You may have to use this definition. Now, c is always your hypotenuse, okay? A and b can be opposite or adjacent. It doesn't matter. It can be any one. But c has to be your hypotenuse. All right? So this is the only part that can be a little tough when we do these problems. You may have to find a missing piece, which I have to do. Let me go back to our problem. Notice I don't know my hypotenuse, right? Let me erase it. Like it's empty. But I do know my a and b values. So let me write this out. I'm going to do a little bit of work on the side. A squared plus b squared equals c squared. I'm just going to start with that. Now, I don't know what c squared is. That's my hypotenuse, okay? But I do know a and b. It can either be, a can be 6 or 2 radical 12, any one you want. So I'm just going to do 6 just to start it off. 6 squared plus 12 radical 2 squared. Now, 6 squared is 36. 12 radical 2, you can do this on your calculators, but if you do it in your head, 12 squared is 144, and the square root of 2 squared is 2. So I'm probably going to have to do this on my calculator right now because I don't know the value of this right now, but I get 36 plus 288. So let me find out what this is. So hold on, I'm just looking at my calculator here. So 36 plus 288, that's 324. And I think that does have a nice square root. We'll find out right now. So what is the square root of 324? Okay, so it's 18. So what I'm going to do at this point is take a square root of both sides. And I get c equal to 18. So my hypotenuse is 18. So I'm going to put that right here. Okay, all you have to do now is simplify. So sine of theta is equal to 12 over 18. What can I divide those by? What do you think? I know a 2 will work. A 6, yeah, a 6 will work really well. 12 divided by 6 is 2, so this will be 2 radical 2 over, and 18 divided by 6 is 3. This is my answer. So that's right here. So let me kind of zoom out and go over everything that we had to do and think about when we did this. The very first thing we did is we labeled our triangle, okay? So we can see what we had and what was missing. And then once we labeled the triangle, I used my trig function, the sine of theta equals opposite over hypotenuse, and I tried to fill it out, right? I found the opposite side was 12 radical 2. I looked for my hypotenuse and I noticed there's no hypotenuse. They didn't tell me. So I had to use the Pythagorean theorem to figure that out. Okay? Once I figured out the c value, the hypotenuse value, then I just plugged it back in and simplified. Okay? So there might be problems where you don't have to use the Pythagorean theorem. There might be problems where you might have to use it. Okay, so it could happen, it might not happen, it just depends on the problem. Okay, so that's one problem right there. Now this only became a little bit more difficult because we had to use this piece in order to find information. Okay, if you don't have to use that piece, then the problems are a lot easier. So let's find a different one here. I think this one was a tangent one. And this one will require the Pythagorean theorem as well. So it's good that we practice that a couple times. So again, I want to label my triangle. First though, let me just write down my definition for tangent. So tangent of theta is opposite over adjacent. Okay? So what is the 8 radical 5? Is that my opposite side, my adjacent side, or my hypotenuse? That's the hypotenuse. Good. Hypotenuse, because that's opposite the 90-degree angle. So that's hypotenuse. Now notice my angle is right here. What is the 16? Is that opposite or adjacent? That's opposite. And again, if you're not sure why it's opposite, ask yourself, does that side touch the angle? It doesn't touch it. So that means this has to be opposite. That leaves this as adjacent. And notice we don't have a value. We don't have a value for the adjacent side. So if I go ahead and start using my formula, tangent of theta is equal to opposite, which is 16, over adjacent, I don't have an adjacent value. So guess what? I got to solve for it. So let's go back to the Pythagorean theorem. Now this time I am not solving for C. Remember, C is the hypotenuse. I needed to solve for the hypotenuse in the previous problem. That's why I solved for C. In this one, I have to solve for either A or B. It doesn't matter what you want to label it. I usually let A be my unknown, just because it's easier that way. But you can make it B. It doesn't matter. But we do know our hypotenuse. Our hypotenuse is 8 radical 5, so that I know what to put for C. All right, so here you go. Let me tell you what I'm going to do here. The A squared, I'm going to leave it alone. Plus B squared, well, that's not my hypotenuse, so I'm going to use 16. And then C squared, that's going to be 8 radical 5 squared. Again, calculator is going to be helpful here, right? So A squared plus 256 is equal to 8 squared is 64 times 5. Okay, so 64 times 5. Let me figure out what that is. 64 times 5 is 320. So A squared plus 256 equals 320. And in order to solve for A squared, I'm going to subtract 256 on both sides. So A squared is equal to 320 minus 256. That's 64. What's if I do a square root of both sides, what's my answer? 8. Okay, so A is 8. Remember, A is going to be my adjacent side. So let me put that up here. I'm going to write it right here. 8. Right next to the word adjacent, or the 3 letters adjacent up here, I put the number 8. Okay? Just so I have something for me to see. Now let me go back up to my main work. So I just got to plug in the adjacent side, that's 8. And 16 divided by 8 is 2. So there's your answer. 2. Okay, so the definitions of sine, cosine, tangent, they're not like crazy difficult. Sometimes what makes it a little bit tougher is that you're going to have to find those missing pieces by using the Pythagorean theorem. That's what makes it a little bit more work. Okay? But like they expect you to be okay using that definition, because Pythagorean theorem, you guys use it a little bit at the end of Algebra 1 or Math 1. You should have used it in Math 2. Right? So they're thinking by Math 3, you guys should feel comfortable with it. Right? So they're not assuming that this is going to be the part that you're going to struggle with. They're like, oh, they should be good. Now, of course, we all know that not everybody retains everything, right, that you've learned before. So, yeah, it might be a little bit of a relearning process, but hopefully you still feel comfortable with it. Okay? So we did a tangent problem. We did a sine problem. Let's do a cosine problem. Let's find one that is cosine. There's actually 2. I'm going to do the one on the right side since it has a little bit more space. Okay? And don't worry, 3 and 4 are pretty much the same thing. One is not harder than the other. They're both about the same in difficulty. All right, so let me write the definition for cosine. Cosine of theta is adjacent over hypotenuse. Okay, so let's look at our triangle here. Let's label my sides. Which one is the hypotenuse? The 20. Okay. Which one is the opposite? The one without anything on it, right? So this is the opposite. That means that the 12 has to be adjacent. Do I happen to have everything I need? Yeah, I got the adjacent side. I got the hypotenuse side. I don't have to use the Pythagorean theorem. So cosine of theta is adjacent, which is 12, over hypotenuse, which is 20. Just simplify. I can reduce 12 and 20 by 4, so this will be 3 over 5. There it is. So this is a good example of how easy they can get. And then the other two we did are a good example of how complicated they can get. Okay? If you're lucky, they'll be just like this, where they gave you everything. You don't have to do anything extra. It's just, there it is. Put your numbers in, simplify. And if you're unlucky, then there's going to be a problem where they give you everything you need except for one side, and you got to figure out that side. Okay? So, you guys want to see another one, or do you want to just try your homework? I can do another. Remember, you have 10 problems. We've done 3. You want me to do one more to at least knock out 40%? Yeah, I see a couple people kind of nodding yes. I know you're not overly loud about it, but what would you like it to be? Sine, cosine, or tangent? Anybody have a preference? No preferences? All right, so let's see if we can do a cosine one that doesn't have, no, that has the adjacent side. We'll do number 8, I think. I'm looking at the cosines, the sine functions, so we'll do number 8 right here. All right. So tangent of theta is opposite over adjacent. Okay. I'm going to label my triangle. So here's my angle. Okay, remember, always label your hypotenuse first. So which one is the hypotenuse? The 9, the 12, or the empty one? The empty one. So this is hypotenuse. All right, then go to your opposite side. Which one's your opposite side? 12 or 9? All right. And adjacent has to be the 9. All right. Do I have everything I need? According to my definition, I need my opposite and adjacent. Do I have those values? Yeah, so this should be easy, right? Tangent of theta is 12 over 9. Now just reduce it. Divide by 3, you get 4 over 3. And there you go. So it's good we got 2 easy ones, right? Because we did 2 easy ones, we did 2 tougher ones. So you can see, like, at its easiest, it'll look like this. At its toughest, it's going to be like the first 2 we did. Okay? So you guys have 6 problems to do. Again, I would recommend you start doing them now. We got 21 minutes, so you can at least knock out 2 or 3 of them.